Hi, this is Math Just in Time. Okay, so let's get started. So if we have x over 2, there's another way to write this. So we assume that there's a 1 here, right, for all of these, but we don't really write it. Okay. And so something that's really important to know is if you have this, you can take the number out like this. So you can take the x and kind of move it over. And this is the same thing as saying 1/2 times x. And let's think, does that make sense? If we have a number and we're dividing it by 2, is that the same thing as saying a number multiplied by a half? Yes, it is. So let's use an example. If we had 10, okay? So if we had 10, if x was equal to 10, so if x is equal to 10, and we had this, we put in 10 over 2, is that the same thing as saying 1/2 times 10? Well, 10 over 2 is 5, and a half of 10 is also 5, so this is the same thing. So for this one, it would be 1/5 x, and for this one, it would be 1/7 x. And this may seem like not that big of a deal, but it's very important because it will make solving equations using division much easier. And as you get further and further into algebra and such, in later math, this can also come in handy to help you break down different equations. So let's look at a couple other examples. Okay, let's look at these two examples. So we have 2x over 3. Well, we can pull the x out and we're left with 2/3 x. Or this one, we can pull the x out and we're left with 7/10 x. So this is very important to understand. And the same goes the other way too. If you're given 7/10 x, at some point you may need to write it like this, but that's down the line a little ways. So let's take a look at this. This is another tip or trick that's useful. So if you have x plus 3, okay, and you're dividing it by 2, we need to kind of be able to split that up sometimes. So that ends up being x over 2 plus 3 over 2. So all we did was split it, okay? So if you can pull this x out and we can make it 1/2 x plus 3 over 2. So this looks a whole lot different from this, but I just want to focus on this just for a second. So what you want to be able to do, if you're going to split this up, you have to make sure the 2, because it's on the denominator, that it goes with each thing on the top. So let's look at this one. If we had x over 5, now there's a minus sign here, and then we would have 2 over 5. So what we did, and we can always rewrite this too as 1/5 x minus 2 over 5. So all we're doing is rewriting things. This and this and this are all the exact same. This and this and this are all the same. But sometimes being able to do these sorts of things can help make your math solving these equations much easier. So it's very important to learn this. Now, what if we had something even further? I don't think you'll see this for quite a while. But it might be important. And I think it's important to see it so that you can kind of make sense a little bit more. If it's on the denominator, it has to go with each thing. So this is going to be equal to x over 5 minus 2 over 5 plus 5x over 5. So you have to make sure that the denominator goes with each part, however many parts there are. And they're always either added or subtracted depending on what you see up here. But this is advanced. This is further advanced, and you'll get to it, don't worry. Okay, The next thing that's really important to understand are reciprocals. Reciprocals are when you have a number, usually a fraction, but I'll show you it doesn't have to be, or any number can be a fraction, and you switch the numerator and the denominator. So if you have this, if you have 1/2 and you flip it, you would get 2 over 1, which is just equal to 2. So 1/2's reciprocal is 2 over 1, or 2. What about 2/5? Well, if we take it and we flip it, the 5 comes on top and the 2 goes on bottom. So 2/5's reciprocal is 5/2. And this one, if we have 7 over 10 and we want to find its reciprocal, we're going to flip it. So we have 10 over 7. And you might wonder, why do I need to do this? Well, there's one thing, and we will definitely use it in the next lesson, that's really, really important. If you take a number and you multiply it by its reciprocal, you will always get 1. So let's look at this one. Whoops. If we take 2/5 and we multiply it by 5/2, its reciprocal, let's see what we get. We get 2 times 5, which is 10, and we get 5 times 2, which is 10. And 10 over 10 is equal to 1. Remember whenever we did multiplication, or when we did multiplication and we had to divide it by a number, and then we were able to make it a 1? I think that may have something to do with division here in a little bit. So let's look at this one. If we have 7/10 and we multiply it by its reciprocal, we get 7 times 10, which is 70, over 10 times 7, which is 70, which will give us 1. And the same for up here. If we do 1 times 2, we get 2. And we get 2 times 1, we get 2, which is 1. So, what about just a whole number? What if we just had a whole number, like 4? How do we find the reciprocal of 4? Because there's not a numerator and a denominator. Well, you can take any number and or any whole number, and you can make it a fraction. 4 over 1 is the same thing as saying 4. So now we can take its reciprocal. Its reciprocal, the 1 goes on top and the 4 goes on the bottom, and its reciprocal is 1/4. What if we had 6? Okay, so 6 over 1 is now the fraction, and we flip it, and we're left with 1 over 6. But does that still work? Well, let's see. We've got 1 times 4, which is 4. We've got 4 times 1, which is 4. We've got 1 times 4, which is 4, which is equal to 1. And 6 times 1, which is 6. And we've got 1 times 6, which is 6, which equals 1. So anytime you take a number and you multiply it by its reciprocal, you always get 1.